Okay, now we're going to build a very basic Stable Diffusion 1.5 workflow, and this will give us an opportunity to learn about the user interface of ComfyUI. And towards the end, I will also show you a workflow that works on a very low VRAM GPU, such as a 10 series with 4 GB of VRAM. Okay, so this is a brand new ComfyUI. You may be seeing something similar to this or may not, it depends on the version. But what we're going to do is just delete all of this information. So I'm just going to zoom out a little bit, hold down Control and draw a square around it all and just press delete. Okay, so I've got a brand new blank workspace. Okay, now the first node we're going to use, if we just double click, we get a search option. It's going to be load checkpoint. Okay, the checkpoint that we'll load into this is Stable Diffusion 1.5, and that's just a very small checkpoint that is good for learning. And if I click that there, there's nothing just there yet. We will need to download that from the internet and put that into one of the ComfyUI folders. Okay, so on my documentation, if I just scroll down a bit, I have a link here where we can download it from. If you click that, it will download the model to your computer. So it's about 2 GB in size. That could take some time. I'm just going to fast forward this video to the point where it's downloaded. Okay, so that has fully downloaded now, and that's it there in my downloads folder. Now we need to put this into where we installed ComfyUI. So I'm just going to Control X, that's to cut. I'm just going to move it completely down to my H drive, into my ComfyUI Windows Portable, ComfyUI Models, and then checkpoints folder, and then right click and then paste. Okay, so that version 1.5 pruned EMA only FP16 safe tensors. That is a Stable Diffusion 1.5 checkpoint. Now, if we go into ComfyUI again, and if you were to click up there and do edit, there's an option to refresh node definitions. Just click that, or there is another way of doing this as well. If you click this one, the node library, and then click that refresh there, it's another way of doing refresh node definitions. And then just close that. Checkpoint name now shows the option and we can select it. Okay, now as time goes on, you will want to use more advanced models, but we're just going to use Stable Diffusion 1.5 for now because we will learn a lot of the concepts, and most of us, even with low VRAM cards, will be able to use this. The more advanced models require much more modern GPUs that support more compact data types. Now, just to go backwards a little bit on the data type here, the FP16, that describes the data type used by this model. On my documentation, if we just scroll down a bit, there's a table here of supported data types. If you have that data type that we installed, the version 1.5 pruned there with the FP16 in it, all the cards that support FP16 natively are anything 20 series or above. These are NVIDIA cards. If you have an AMD card, you'll have to look up its specs. Okay, now 10 series cards, which some of you will have, don't support FP16, but it will still work. What will happen? There will be a slight reduction in speed in processing because it will have to convert the FP16 in this model to FP32, and that will use up twice as much memory as well, so which makes it even harder to use on a low VRAM card. But I will show at the end of the video how we can get around that. But anyway, so if you do have a low VRAM card and you're running this, just continue along. You should still be able to generate images. It will be very slow, but I'll show you how to speed that up as we progress. Anyway, we have a checkpoint loaded. Now, also what's very special about these particular checkpoints are that they are actually a bundle of components. So it's one file that we've downloaded named that. Inside that, it's got a diffusion model, and that's the core neural network that denoises what's called latent noise into an image over multiple steps. So we'll generate the workflow that uses the UNet or the diffusion model inside this particular checkpoint that we've selected. It also has a text encoder. This is converting the text prompt that we'll write into a numerical embedding or vectors, and the variational autoencoder. It encodes images like RGB, like photographs, into latent space, which is more about numbers in dimensions. Or another way of looking at it is it's getting a photo and creating a really compacted, blurry version of that in some way. This is what the AI model will work with. And then at the end, we'll decode back into a image that contains colors and looks like a photograph. And that's what we're really trying to do. But the one file that we downloaded there, that contains all 3 components. Other models that you will see as we progress won't contain all of those components. We'll just have to individually download them and select them. But right now, everything is in one file in that 2 GB file that we just downloaded. So that makes it much easier to begin with. But anyway, things will get much more complicated as we progress. But anyway, continuing with the model part, that's the UNet or diffusion model I just talked about. We need to pass that into what's called a KSampler. Okay, so when I drag that out like that and let go, it gives me some suggestions there already, KSampler. Not all suggestions will be on that small list, but the KSampler is what we're using in this case. So the model goes into the KSampler like that. Okay, now this KSampler is what will be doing the processing using all the different components, and that will all happen in what's called latent space, and then after it's finished it will output to an image. But we need to convert that latent information back into an image, so we use a VAE Decode in that case. So I'm just going to put that up there, and then we get an image, and we've got several options here. The first one I'm going to show is called preview image. Okay, so that's just going to draw an image on the screen. It's not going to save it to the file system just yet, and that will auto resize once an image has been created. But you can see here the VAE Decode needs a VAE option, so we can get that straight from the checkpoint that already contains that VAE component. Okay, so that's joined up now. These lines, after a while you get quite used to them. They don't really bother me, the fact that they go across the screen like that, but you do have options. You can either hide them if you like. There is an option down just behind me, just down there bottom right there, hide links, so you can hide those, but I prefer to keep them on like that. You can also change how they look. So in here, in settings, light graph, link render mode, here, straight lines. So if I just go out of that, they're more straight lines now. Let's do that again. Settings, light graph, link render mode, linear or hidden. I'm just going to keep it with spline. Okay, there it is there, and close that. Now continuing, that's not going to work just yet. We still need to do more. We can see here that a lot of these inputs haven't been filled just yet. Now, these positive and negative, the positive prompt is where we write in text what we want to see in the final image. So if we just drag that out, it's giving us some options. So CLIP Text Encode, like a little tiny notepad there. Its output is what's called a conditioning. And actually you can see that it's orange and that goes to orange as well. So we can see that's compatible. Whereas over here, you can see the VAE is red and that's compatible. The model is compatible. So you couldn't drag from one color to a different color. It's not going to let you like that. But if we just look at that, there's that kind of yellow. We can see down here, there's a yellow as well. So that's actually going to go into there like that. I'll just move that out a little bit. Anyway, let's do that again with the negative prompt. Now there's multiple ways of doing that. We can drag it out and create another CLIP Text Encode like that. Or we could go from that end, drag out and create a CLIP Text Encode and then finish it off like that. I'm just going to press Control Z a few times. Or we could get that one, do Control C, Control V to paste, and then join them up that way. Like that and like that. Now I'll just reposition them slowly. So that is the positive prompt. That's the negative prompt. And so we've got 3 things going in. We need one more thing. But first, let's look at these prompts a bit more. So the positive prompt, I want to see something. I want to see an apple on table, for example. And the negative prompt is what I don't want to see. So I don't want to see, normally you'll see things like watermark or text in the image. And with SD 1.5 models, and actually many models that you'll see, that's a common thing to say I don't want to see, because a lot of these models were trained on images that were dotted around the internet in some way, and they may have had text or watermarks on them. So that's quite a common one. You'll see lots of different kinds of variations in there. But anyway, still not ready yet. Now I can see that we need to add the latent image now as well. Okay, so instead of actually setting that up right now, I'm just going to show you what happens if we try to run it. So if we run it, it's telling me already that there's a problem. Okay, execution failed, required input is missing latent image. Okay, here it's drawn a red around the node and it's drawn a little circle around there. So we can see that that is the problem. So the UI is quite helpful like this anyway. So what we can do is just drag that out and take something that is compatible, and that there is empty latent image. Okay, and it has dimensions of 512 by 512. Now this model here, this Stable Diffusion 1.5 was trained on images of 512, 512. So that's the best latent image to use. So we'll talk more about that in the next video, and most of these other details also in the next video. But right now, we just want to see this working. So that's everything now connected. I'll just move that up a bit higher. I'm just going to reorganize it slightly. That's good. If I just run that now, okay, so that green is indicating where we are right now in the workflow. It loaded the checkpoint into memory, read the prompt, an apple on a table, looked at the negative prompt. So just in case it was generating anything with watermarks or text in it, it was going to remove it. The KSampler is where all the work was done. We'll look at all these settings in the next few videos. And there we go. There's our output preview image. If I just make that a little bit larger, and that's quite good quality, really. 512 by 512. And that was quite fast. So okay, and since this has been set as randomized to seed, let's generate another one and we should get something else. Okay, another one, and we can make as many as we like. Okay, also, if we look here at this queue option here, these are the images that I just generated and how long it took, 2 seconds, 228, 458 for the first time, because it was actually loading the checkpoint into memory as well. If we just look at another feature there, every time you run that, it's not reloading the checkpoint into memory, it's already there. So the only thing it's going to do is start off from the place where things were changed. And since this is randomizing the number after generation, as it says there, control after generate, only the KSampler has any change to it. So if I run it again, it will start from the KSampler and then finish those other parts like that. I'll show that again. But if I made a change to the text, for example, an orange on a table, then it would load that bit, run. Okay, it was so fast we didn't really see it. And if I changed the checkpoint model to a different one, we only have one right now, then it would start from there again and out. Okay, so just be aware of that. So it's only going to start off from a bit where there was a change. But anyway, more about all these settings in the next video. Okay, now just one other thing that is happening on this screen. This is a new feature in ComfyUI. If I was to remove my face for a moment, just behind me here is this little workflow mini map. You can move that around like that and you can zoom in and out using that. This is not something I tend to use myself, so I will just turn it off. But if you do want it back, press Alt M on the keyboard and it'll come back. All right, so that's the little mini map. Also, here we're doing preview image, so we're not actually saving these images to disk. So if I go out here, I'm going to drag another one out and do save image. And that will save with a file name prefix, but we've got plenty of options there. We can name anything we like, A, B, C, whatever. I'm just going to leave it as default, but we've also got the option to use formatting, such as the date format or empty latent image .width to include values from nodes. Okay, but anyway, if I generate now, we can see that it will save, and I'll just run that. It will generate right now a image that's saved to disk. It's also given us a preview, so we don't really need both of them. So I can delete that one and just use that one, and then just make that a little bit bigger. Let's generate another one. Generate another. And if we look into the file system, okay, so H, ComfyUI, Windows Portable, ComfyUI, and then output, and these are the images. So all images that you output, as long as you're using the save image node, will be saved to the file system and prefixed with those letters as I've got written there. So ComfyUI. So you can change that if you like. Okay, but those other ones I did before with the Apple, they aren't saved to disk because I was using the preview image option only. Okay, now also with this output folder, I'm just putting the two side by side there. These images also contain the actual workflow that was used. So if I was to drag that image there into ComfyUI like that and let go, it creates a new workspace, ComfyUI 001, same file name, of the actual workflow that was used to generate that image. So I could just run that again and reproduce that same image like that. So remember, I had the preview option open at the same time as well. So that's a good way of sharing workflows with your friends or colleagues. Let's look at another one where I remove the preview option. Okay, so if we just look at that, yeah, it's just the save image there. So if I ran that, okay, it's identical. Okay, so you could just send that in an email to your colleagues and they will be able to drag that into their own ComfyUI. And that should work provided that they've got the same checkpoint as well on their system. Okay, and another way we can do this is that you can host these images on a website. This is my documentation website. This particular image here has a workflow in it. So you could just drag that from my website into ComfyUI, and there we go. That's the actual workflow used to generate that image. And then you can just run it, and there you go. That's that image created. Now that works straight away because we already have version 1.5 Prim DMA only FP16 installed. Okay. Now, with this particular workflow that I've been showing, this is very much the same workflow, just laid out slightly differently. You can see that we can just drag those images back into ComfyUI, and that's a pretty good way of backing up your workflows, just by generating an output that you can drag back into ComfyUI later. Now, there's another option to this particular workflow as it is now. I could also save that. So up here, File, Save As, and just call it default SD 1.5, for example, confirm. Okay. Now I can load that again later if I need to by going to workflows here, and there it is there. That's the workflow that I just saved, and it's already opened up. So if I click it now, it makes no difference. But if I just close it and then open it, there we go. It's open again over there. Okay. So do save it because we'll use this basic workflow quite often as a starting template to build more complicated workflows. Okay. Now moving on, if you are using a 10 series video card, your image generations would have been quite slow, not this 2-second average that I'm seeing here. You will probably seeing like a 1 minute average if you're using a 1050, especially with 4 gigabytes of VRAM. We can make 10 series cards much faster by introducing a LoRa in the middle of this model line here, which is going into the KSampler. If I just drag that out and we search for, we can use the LoRa loader, but instead I'm going to search for LoRa only. So load LoRa model only. Okay, so it's only got one input, and then that model will go in there. Okay, so now we've intercepted that model line with a LoRa loader model only. We're going to load a specific LoRa, which is designed to generate models using less steps. That down there says steps 20. We'll talk more about this in the next video, but this particular LoRa that we'll use allows us to use 4 steps, and that means the image will be generated much faster. And there is a compromise with the detail of the final output. It's not quite as good, but if you're running low VRAM GPUs, then it will be very beneficial for you so you can continue following along with the course. Okay, so we need to get that particular LoRa. We don't have anything yet, so it says undefined. We need to download that from the internet, just like we did with the pruned EMA only just there. So on my documentation, if we go further down where it says low VRAM GPUs, there's a link here. We can download this file, PyTorch LoRa weight safe tensors. So click that. That's the file just there. So we can download that. It's only 135 megabytes. It's very tiny, so download that. Also, the name is very ambiguous. Some models you'll need to just rename them because they all have the same name. So when that's finished, I'll just rename that. Okay, that's downloaded into my downloads folder. There it is, PyTorch LoRa weight safe tensors. I'm just going to rename that to something more descriptive. So rename LCM LoRa SD15 safe tensors. So I know that this particular LoRa here works on Stable Diffusion 1.5, okay, or anything based on the Stable Diffusion 1.5 models. And we'll talk more about that later. Okay, so copy that. I'm going to do Control X to move it. I'm going to go back down to my ComfyUI models and go into a LoRa's folder this time and do paste. Okay, so that's there. Okay, so that's also written here on my documentation. Now back into ComfyUI, refresh node definitions. So there's multiple ways of doing it. Right now, depending on your version of ComfyUI, it's either here or there, or it's here in the node library. Okay, node definitions updated. Now, if I select that, it's available in the list. All right, that means I can now reduce that to a 4, that to a CFG1, the sampler to LCM. It's an LCM LoRa that we're using. LCM stands for Latent Consistency Model. It's just a method of speeding up the generation process. And the scheduler use SGM uniform. Now, these particular settings are what you use, or you can use between 4 and 8 on this particular LoRa here. And that will now generate images much faster. So run that. Okay, so that's an orange and it's quite okay. There's another one, another one. Another one, and that's generating much faster on my computer because my graphics card is actually quite okay. But you can see it's 0.45 seconds now, 0.41. So it's actually, instead of averaging 2 seconds, I'm averaging just under half a second. Now, if you have a 10 series graphics card, this step that I just showed you where we load the LoRa model only and then we set the steps to 4, CFG, 1, sampler, LCM, SGM uniform like that, will benefit you greatly. But if you don't want to do that, you don't have to. It's just a way to make doing these lessons much easier for you. Okay, so that's just an important distinction. If you have a low VRAM card, I recommend using this LoRa loader model only and set these values so that you can at least participate. You won't be able to go through the whole course and make videos, but at least you'll be able to do all these Stable Diffusion exercises. Okay, so anyway, just to summarize what we went through, I talked about the link colors there. So you can see the colors all match up with the inputs and outputs. We can change the link styles to straight lines or even hide them completely. There's a queue which you can use to go backwards in time and look at something again. You can actually just even get that and drag that into ComfyUI as well. And then you got your workflow again. But I'm not going to use that. If you delete everything, doesn't really matter because there are ways of getting your work back. For example, the output folder where all those generations were saved. So you can just drag that back in if you like. And many of these images on my website, you'll be able to drag in as well. Just another quick thing I didn't show you yet. This output folder is something that you will come back to all the time. And instead of having to navigate through your file system and going ComfyUI, Windows, etc., all the way down until you find the output folder. If you right click it like that, you can do pin to quick access. So on my quick access now, I've got an output folder, so I can go to it instantly. The other folder, which is very useful, something you'll use all the time, is this models folder. So if you just pin that to quick access as well. So here I've got models, and this is where my checkpoints went before. I put that there. And I just put something into LoRa's as well to make it work on the lower end graphics cards. Okay, so you'll be able to customize those however you like. So there we go, output, models. And as time goes on, you'll find other folders more beneficial. Actually, the one I use most, and actually a good one, is even just putting ComfyUI into your quick access. There we go. So there, ComfyUI, there's all those there, there's the models and there's output. It's really up to you how you prefer to do this. This is what I do. Okay, so hopefully you are able to generate images in your ComfyUI now. And if you had a 10 series graphics card, you would be using the LoRa option. And I do have some LoRa outputs there. Okay, that one there was a LoRa option. So I just dragged that in. Okay, that uses the LoRa loader model only there, the LCM LoRa for SD 1.5 models. Okay, so SD 1.5, and that is another way of suggesting SD 1.5. A lot of these things are all written by different people, so they will all use slightly different naming schemes, but you just get used to it after a while. You'll figure it out. Anyway, excellent. In the next video, we'll look at a lot of these settings here that we see in the KSampler and the latent image and the text prompts, and do a little bit more messing around with the user interface. Anyway, excellent.